So good morning and welcome to the first session in the Big Data track. Thanks for coming to reInvent. I hope you all enjoyed the keynote this morning from Andy. Very exciting for me to watch a bunch of the stuff that we talked about, and I hope you all found it good too. So this is the first breakout session in the Big Data track, the Big Data State of the Union. So what are we going to talk about, and what would we like you to be able to leave this session with? So this is a 100 level session. It's the kind of the mini keynote for the Big Data track. It's an introductory session where we'd like to spend some time. I have two great speakers who are joining me, Scott Hagedorn from Analect and Lisa Green from the Common Crawl, so we can hear in their words the kind of things that they're doing and that enable them with big data. So we'd like you to leave this session having a kind of idea about how we're thinking about what we do for you as our customers or our potential customers with big data, and then hearing in the exact words of one of our customers how some of the building blocks and some of the services that we develop can be useful. Spend a little bit of time overviewing what those building blocks are that we provide. Lisa's going to spend some time talking about big open data and how the cloud can help with that. And then kind of give you a signpost. There are a lot of other deep sessions. If there's anything in this presentation this morning that you find interesting and that you want to go and learn more about, whether it's Elastic MapReduce, Redshift, Data Pipeline, or any of those other services, there are a lot of other deep sessions that you can go and learn some more. So that's the kind of thing we like to get out of the session. What do we want to do from a big data point of view at AWS? What do we want to enable you to do? We want to provide you with a very broad range of tools and technologies so that you can work productively with data at any scale, whether that's from gigabytes to terabytes to petabytes and so on. And a whole choice of tools. Services that are both broad and deep to support any kind of imaginable use case that you can think of from the point of view of working with and processing your big data. We also want to make sure that we're very clear along this continuum that we want to give you the choice. We want to give you the choice that if you want, as you heard in the keynote this morning, as you're going to hear in some of the case studies, we want you to be able to invest your capital. We want you to be able to invest your resources into doing the right things for your business, not doing undifferentiated heavy lifting. So if you're going to run a data warehouse, if you're going to run a Hadoop cluster, we would love to do that undifferentiated heavy lifting on your behalf, so you don't have to procure infrastructure, you don't have to have people administering it. You can focus on dealing with your data. But we also want to give you some choice. We participated in a panel recently talking about different distributions of Hadoop, and the theme was what's the right Hadoop distribution. And to a certain extent, we don't have an opinion. We have a set of options for you, so you can choose what you want to use. If you'd like to use Amazon Elastic MapReduce and have Hadoop taken care of for you, we would love for you to do that. From a database point of view, if you've got needs for a NoSQL database, we would very much like you to use DynamoDB if it provides the capabilities and the features that you want. But if you want to go and deploy something where you have absolutely full administrative control and deploy your own infrastructure in the AWS cloud, then we're more than happy for you to do that as well. So we want to provide you with a lot of different choices. You can have the service managed for you, or you can do some work to build your own, if that's what you would prefer to do. And then also have the choice of deploying your applications and working with your data in a place that's convenient for you. We've got a set of regions and availability zones right now, and we're only going to be adding to them as time goes on. So when we think about big data, we have a concept of something that we call the data timeline, going from the production and generation of the data on one side all the way to the other end, where we would think about how we can collaborate and share with that data with people later on. Now, I think we all know there's no problem generating data now. Any customer I talk to, it's not a problem that they don't have an ability to generate logs to analyze or other pieces of data they want to look at. But it's the other things that can traditionally be constrained, whether that's smaller startup organizations or large enterprise organizations. Being able to process that data, being able to store that data, do the right kind of computation and analytics, and then ultimately share it. These are the things that when I talk to customers tend to be more of the problems. We have some analysts who talk about this. The volume of data generated is really increasing, but some customers feel that maybe the ability to analyze that data is going to be more of a challenge. So we really want to think about how utility computing can remove those constraints, and whether that's for Smaller organizations who know they're going to be dealing with a lot of data, and we've got examples later in the presentation of those types of organizations. Whether it's traditional organizations who have a lot of data and they just want a way to be able to process it in a way that they couldn't do before. Whether it's what Lisa's going to talk about later on, that with a credit card and a data set that's stored in AWS, anyone can do these really useful kind of computations and processing. We really believe that utility computing can remove these constraints. And we want to get to a place where that data timeline is without friction for you. So all the data that's generated, you can process that, you can use these building blocks that we have to offer you to get value out of that. So to make that more real, before we start talking about some of these building blocks, I'm going to ask Scott Hagedorn, the CEO of Analect, who's kindly agreed to join us. I'd like to invite Scott on stage, and he's going to talk about how utility computing and some AWS building blocks have helped him. So please welcome Scott on stage.
Thank you. So when I was asked, I'm an advertising guy, when I was asked to come to a conference to address a lot of engineers, I was like, are you serious? You really want me to do that? So my company, Analect, works as part of a broad advertising, holding company called Omnicom. We are the data and software side of the equation, which might sound foreign in the advertising space, but it's becoming very real. 90% or so of the industry that exists still operates in kind of an old school manner, but there is a 10% or so very disruptive force that's starting to kind of come up within advertising and marketing, and we're sort of happy to be on the tip of the spear of that. So first thing I thought I would do is reveal a bit of a dirty little secret. If you don't know how advertising works, I'm going to show you how it works right now. So imagine, going way, way back in a piece of string and understanding where does an idea come from? How does it work? How does it manifest itself ultimately in a marketing campaign? We're going to kind of do a little bit of muckraking right now, if you will.
How would you describe your dog's temperament?
She's picky, and she's nervous sometimes, but she's very smart.
And yours? He's independent, He knows what he likes. He's pretty hard to fool.
Oh my God, they're describing themselves.
This your first group?
The focus group is where big ideas come from right now in the advertising industry. It's a culture of M&Ms, of one-way mirrors, of people watching people's dogs eat dog food and describe themselves. This is where the big insight typically comes from for the beginning of an advertising campaign. And oftentimes, somebody like myself will make up some kind of bullshit word like joy bombing or something fun that then makes it all the way down the equation and, oh yeah, we should be talking about joy bombing. People are really into joy bombing these days. And then boom, you get a big idea. And then let's talk about how the go-to-market strategy typically works. It's a bit of a game of telephone, constantly losing some of its integrity with people talking to people saying, okay, do you have this audience? Do you have that audience? No, I don't have one, but I have one that kind of looks like this. And ultimately, $1 billion, $500 billion will move based on some hypotheses on where an audience is, where a target is, what they look like, what's going to be most resonant for them. And ultimately, when you put some weak idea, potentially that's been coming out of a focus group, with a not-so-great marketing and go-to-market strategy, you end up with what I equate to a loose nuclear warhead in the market. You don't know if it's going to work. You do know that it's going to hit somebody. You might have Slim Pickens from Dr. Strangelove writing the nuke down, but no one knows if it's actually going to be effective. No one knows if it's going to be resonant, because inherently it's all qualitatively based. And what's going on right now is the industry is actually changing. The culture is changing, and it's tough for some people to swallow. I'll let the mushroom cloud happen. That one apparently worked. Because data is inherently changing our business. Marketing is becoming about a data business. And a great example of that, I'm trying not to knock the computer off here, is if you look at Vatican Square from 2005, when they elected 2 popes ago, versus 2013, our industry now is awash in data. The signals, the contextual, geographic, behavioral, and demographic infinite amounts of data that are coming from devices are constantly changing our industry. And so we are moving from an industry that was all qualitatively based and struggling to become an industry that's more quantitatively based. And if you get down to what's really happening, which is that TV is shifting into devices, all of the devices that the TV and the content is shifting out to give off a huge amount of data exhaust. Like I said, contextual, geographic, behavioral, demographic data sets, mobile data sets, tons and tons of data. Now, in our previous environment, when we tried to deal with that much data to create tools, to create applications, to change the marketplace, our servers exploded. My CTO and I, Dean, and my engineering team and the aggregate knowledge team who we work with are both here. We had some fun and did take a can of gasoline to an old computer to put this together. So anyway, the servers exploded. So what we ultimately need to change the marketplace is we need a stronger cloud-based environment. And what we've put together is essentially a complete new cloud-based infrastructure to run our advertising practice with a lot of the technologies that Paul was referring to a few minutes ago. So we've built out a cloud-based environment where all of our data goes into, including, and most importantly, all the digital data that we have running through the holding company for all digital touch points, which we work with aggregate knowledge on. We're the first big company, I think, to move in this direction. So essentially, we've built a huge cloud-based environment to create new tools, new technologies, new applications to do marketing and to do advertising. And we're moving quickly to a place where marketing is on an always-on state and increasingly becoming somewhat artificially aware. Some people refer to it as programmatic, where there is a loop between performance and insight and activation, or how you actively go to market with advertising dollars. Infinite marketing or programmatic marketing, you could really use either way to look at it. And what we're increasingly doing in that cloud-based data environment is we get all the digital data that we have coming out of the kind of first-party spaces, and we're oftentimes now fusing it with clients' CRM data sets, sales data sets. This is where Amazon becomes very interesting for us because of the amount of data both that we're able to work with them on from their advertising practice perspective, as well as the advertising, the data that we're allowed to and increasingly generating. And so I'll show you now a couple of the applications that we've actually built onto this environment. So this one sort of replaces a focus group. We built this for an automotive client. It's fusing JD Power data, Polk data, their first-party CRM and sales data of people that are coming off of lease or that have bought a car before. And it tells you everything you need to know about this audience. What do they look like? What are their media habits? What influences them? Why do they buy what they buy? And this has become essentially the planning tool that is the jumping off point now for coming up with insights and for coming up with creative ideas. Instead of it being qualitatively based in a focus group, it's becoming inherently quantitatively based. We've also rebuilt sort of how we go to market from an advertising perspective as Wall Street changed. So we basically mirrored Wall Street, and we now increasingly are trading media and trading advertising like stock in real time. And the industry is going this way, which is, again, very disruptive. So our trading interface, and this is built within the data management platform environment with aggregate knowledge, but this is building essentially right now an algorithm that's both geographically based and weather-based to activate advertising inventory in real time. So essentially, you're building your own trading algorithms in real time to take them to market. So planning has become, or coming up with the insights has become increasingly quantitative, and advertising itself is becoming increasingly programmatically driven like stock. And then on the back end of it, we have our analytics performance systems. So to Paul's point about moving from the data generation all the way down the continuum, this is where we're actually sharing the performance results directly with the clients, and all the computation is happening behind the scenes in the cloud-based environment where we've put all the logic in and we've piped all the data into it. And this is now all integrated into one software platform for doing marketing and advertising that did not exist before and could not exist before we entered the cloud environment. Two more quick examples. When we talk about how much data we're ultimately generating, this is where it ultimately all flows into. So this is looking at across multiple clients, across multiple industries, across multiple geographies. at the sheer volume of data and impressions that we're able to work with. So at the core of everything I just showed you, planning, trading, analytics, there is a data heart to it where everything flows into it in the cloud-based environment, as I mentioned. So just to wrap it up, if I can leave you with anything, is that we're headed into a space where marketing is infinite, is always on, is aware quantitatively. It's a combination of HPC and big data, and we're enabling that through cloud-based services with Amazon and with aggregate knowledge. We've built a very interesting infrastructure where we're combining infinite storage capabilities with infinite data capabilities and then infinite computing capabilities to build our new set of tools. And increasingly, it's becoming artificially aware, which I wanted to introduce my new company to you, Skynet. And you can anticipate that in the future, I will have marketing drones that are coming to seek you out and sell you things, but I promise that it's not going to be like the T1000. We're instead going to go with the sexy Cylons. So thank you.
Thanks very much, Scott. And I hope you all found that useful as a kind of a meaningful example of how one of our customers is using these services together to get some value. So now we're going to spend a little bit of time talking about some of those building blocks before Lisa comes to talk to us. So to give me an idea of what people are using in this room, how many people are using DynamoDB today in here? Good. So some people are definitely, hopefully, at the right session. That's a good thing. And what about Redshift? Good, so some Redshift customers in the crowd, and Elastic MapReduce. Okay, good. A good mix of people. How many people are running Hadoop but are not running Elastic MapReduce? Does somebody have? Small number. Okay, good. So when we look at some of these building blocks that we'll go into some of them in a little bit more information than others. We've got things like S3, our object store, where lets customers store, effectively an infinite amount of data, no need to provision what they want up front. They can just store that stuff and then work on it, whether that's using things like Amazon EC2 instances or taking it into things like Elastic MapReduce. Amazon DynamoDB is our fully managed NoSQL database. For those of you who are using it, probably not going to tell you anything new. For some of you who might not be using it, hopefully we'll talk about what that can do for you later. And then some other tools that are useful for managing data, things like, I can never remember whether it's Glacier or Glacier. Growing up in England, still processor, some of this stuff is still difficult. But a way for longer-term archival storage. For getting the data in the first place, things like AWS import and export, where you can send us hard disks via a courier. And then also, Andy mentioned this before, is anybody using Direct Connect in this audience today? So a few people. So Direct Connect, giving customers a way to have provision private connections, which might be good for latency or the kind of the rates of data transfer or privacy concerns. From a computation point of view, we have a whole different spectrum of Amazon EC2 instances that can do that work for you. You could use those instances on a standalone basis if you were going to do something like deploy your own Hadoop cluster, or if you're using things like Amazon Elastic MapReduce, those will be configured on your behalf. So those are some of the kind of the more building blocks. Some of the other broader services that we have there, Elastic MapReduce and Amazon Redshift, we'll talk about a little bit more. And that's where we're doing more of that management work for you, rather than you having to do work to deploy that. So we're going to start off talking about DynamoDB and briefly introducing what that is. So one of my favorite services, a fully managed NoSQL database service. And some of the highlights for that, it's one of the earlier fully managed services that we launched from the point of view there's no administration for customers. Very low latency, single-digit millisecond latency typically, and running on SSD storage nodes at the back end. Very, very easy for customers to scale. There's no work to do from a planning infrastructure point of view. Performance is very predictable, and I hope you saw some of that earlier when Andy was discussing that, and something that's highly durable and available. We do the work to replicate the data in different physical locations, so it's very, very good from an availability point of view. And the scale, this is one of the things I love about this service when I talk to customers, that scaling DynamoDB, it's our problem. It's not the problem for a customer. You're effectively telling the dial. You start off with a small amount of throughput, you tell us what you want, and we do that underlying provisioning. So you tell us what you need. If you start small, that's fine. You want to grow later, that's fine too. And we do all of that infrastructural heavy lifting of provisioning any kind of computer and storage underlying stuff. All you need to worry about is doing queries and reading and writing data from the database. One customer, just to give an example of scale, AdRoll, who've been bidding on more than 7 billion ad impressions a day. I don't know whether anybody's seen this tweet before, but I love it. For DynamoDB, this doesn't mean that they're all, eating lots of bad junk food and so on, but it's a great little soundbite from our point of view that they spend more each month on snacks than they do on DynamoDB. And then they're also freeing themselves from having to do any of the kind of administrative or management work for that database. A bunch of momentum since we were last at reInvent. We've introduced some price reductions and an offering to reserve capacity, similar conceptually to how you might have reserved instances in Amazon EC2, local secondary indexes, fine-grained access control, so making it much easier for developers to not have to deploy a proxy tier for doing authentication, but integrating with IAM, Identity and Access Management, to do that authentication, meaning you don't have to spend time on building more infrastructure to do that. You can use the feature that's in the service. We also introduced a local test tool, as we're calling it there, to make it easy for developers, as we said in the blog post, to do testing and development work, provisioning with Dynamo, whether you're on the beach, in the office, but without having to do stuff on the live service. So that's a little bit about DynamoDB. The next service we want to talk about, Elastic MapReduce, and its most simple, manage Hadoop clusters in the cloud. The service has been around for quite some time now. More than 5.5 million clusters have been launched by customers, and we're pretty happy with what customers tell us about the growth of that. And a fairly simple, fairly straightforward offering, manage Hadoop in the AWS cloud. We worry about provisioning and managing the clusters, replacing failed nodes, doing that kind of optimization. You get to choose the cluster size and the type. You can integrate with Spot instances, so if you've got some work that you want to get done more quickly. But out of interest, of the customers who use Elastic MapReduce today, how many use Spot instances with EMR? Could you raise a hand? Not many at all. So the Spot market, this concept of being able to bid for excess compute capacity so you can get it typically at the price that's going to be significantly lower than on demand, can mean if you've got work that you need to speed up, you could add more, you could use some Spot nodes instead of having to use on-demand pricing. And you still get access and underlying control to those instances that are there. Conceptually works in a pretty simple fashion for customers. Store your data in the first place and code in an Amazon S3 bucket. Choose to launch your cluster, make some decisions about what you're going to run on the cluster, the programs you're going to run, and so on. And the cluster will start, take the data from S3, and ultimately you can choose to have that data stored back in S3, shut the cluster down, and do it for a very short period of time. So you've got lots of flexibility there. Instead of having to run this on-premises cluster that's going to be a fixed size and effectively able to do a fixed amount of work, you can start with one size of cluster. If you need to do your work more quickly, you can resize your cluster, you can add nodes, you can make it bigger, you could start it bigger, you could have multiple clusters that are different sizes. And it might not be about doing one piece of work. It might be that you need to do different pieces of work. And with that data set being stored in S3, you could have multiple clusters that are all running against that data set at one period of time. One customer who's not in the presentation, but who I was talking to recently, was Channel 4, who are a broadcaster in the UK. Typically, out of the kind of the main original broadcasters in the UK, Channel 4 is a public service broadcaster, but one that still sells advertising. So they had this huge amount of log data that they were finding they couldn't really process it in their existing on-premises relational database system. So they decided to use Elastic MapReduce. Found they could get the data in there very, very quickly, very compelling to them from the point of view that they didn't have to spend money investing in on-premises infrastructure because they didn't want to do that. But they also developed and changed a couple of things. They developed something internally they called the Big Data Control Panel. So they put the power of Elastic MapReduce in the hands of their analysts directly. So if our analysts needed to go and get some data, through this self-service portal that they developed, they could spin up an EMR cluster, do the work, and get their results. So have all of these different clusters running on the data set that they had at that time. We also wanted to highlight a study that's recently been done by one of our partners, Accenture, the Data Platform Benchmark Study. You can find this on the AWS website. But customers often who are used to on-premises environments might be asking questions about how does this work from a cost point of view, how's the comparison work there? So we had some good results that we wanted to share in this paper. If you go to the AWS website, on the Elastic MapReduce page, you'll see a link to that right at the start. But the results they found, Hadoop as a service offering a better price-performance ratio than doing this on-premise. The cloud giving more opportunities to get better performance out of these clusters. And the fact that you don't have to do that tuning, you don't have to deploy, you don't have to have administrators in your organization doing that kind of work. Recently launched a new console for Elastic MapReduce, which we wanted to share with you. And also share one customer success story from S&P Capital IQ, who like what they get from EMR because it's very easy for them to flexibly spin up some clusters, quickly test and deliver new ideas. And hopefully that resonates with some of the stuff that Andy was saying this morning, that they didn't have to go through a complicated capital expenditure program. They didn't have to deploy that infrastructure, but they could very easily experiment. They didn't need to train people up on learning to manage these clusters, even if they were going to do it in the cloud, but made it very, very simple for them. So some of the things we've done recently here, Elastic MapReduce is available in the GovCloud region. We also support MapR M7 to make it easy for kind of high availability clusters and so on. And very recently have launched a new console, making it much faster and easier for customers to use the service. Redshift. How many Redshift customers were there in the room? Could you just raise your hands again? A good number. So I hope you like what you get out of the service. So Redshift was a service that we announced approximately a little bit later, this time last year at our first reInvent conference. And it's a fast, simple, petabyte scale data warehousing solution for less than $1,000 per terabyte per year. And some of the tenets of when we built that were making it very, very easy to provision. And we'd heard from customers, provisioning and deploying data warehouses was typically something that was difficult. So we brought the AWS way, the same kind of thing that you'd hear about we announced with Amazon Workspaces from a desktop point of view, but making it really easy to provision stuff. A pay-as-you-go model with no upfront costs and no reason to commit. Something that's fast, easy to use, and with SQL. So if you've got those kind of skills in your organization, you can launch this data warehouse, someone can have a SQL endpoint, and start being productive very, very quickly. And we see a variety of different use cases, whether it's traditional enterprises who are doing that kind of work there, companies who might not be a traditional enterprise but have a lot of data, and you've heard how that might fit in from Scott, and software as a service companies as well. And you'll hear examples from each of these customers in more depth if you go to the Redshift session that we've got later on in the big data track. Being easy to use was a very important thing for us in Redshift as well, making it easy to provision this very quickly, monitor what's going on, resize clusters so you can get stuff done more quickly, make the service secure, and make backups automatic as well, so we can keep your data secure. And I wanted to include a screenshot for those of you who've not used Redshift. I mean, this is a game-changing thing for customers who would have deployed data warehouses in the old way of doing it on-premise, that they can now fill in some things in the AWS Management Console, click a button to launch the cluster, and that provisioning happens and gives them a SQL endpoint that they can start to be productive with. And the clusters can be resized as well. The click of a few mouse clicks from the AWS console, the cluster can be made bigger if you want to do more in less time. And it's not a kind of you have to start big. You can start small with Redshift. You can grow clusters. You can start seeing how you like the service with smaller types of instances, and then you can grow those clusters later. And we've priced the service to make sure that you can analyze all of your data. So something that not only is easy for you to do and quick, easy for you to be productive, but also extremely cost-effective. One of the things we've heard customers like about Redshift, and one of the things we've worked very hard at working with partners, is making sure that we have a good ecosystem so you can continue to use the tools that you're used to using with the Redshift data, with the Redshift clusters that you launch. And one customer I wanted to highlight who likes what they have with Redshift is Foursquare. And the specific reasons that they looked, I mean, Foursquare is something that I certainly don't have to, unlikely I have to introduce that company, but many, many people are using Foursquare, a lot of data going from those check-ins. And before Redshift, not only did they have to pay for software licensing that they didn't necessarily want to consume in that way, but they had to have people who were doing and managing and running this system instead of focusing on improving what they were doing for their end users. So they chose to move to Redshift, saved a lot of money in terms of software licensing, freed up people so that they could go and do other things that were more important to their business, and ultimately had a great experience based on what they'd had before. So Redshift likes data. If Redshift likes to eat cake, it's coming up to the anniversary of when we announced it. And we've been extremely happy with what we've been able to do on your behalf from an innovation point of view. 26 launches of more than 40 features since the service was announced, and we hope to continue that pace. Really, really happy. Some of the things that we did there, expanding the global reach of where Redshift is available in different regions. Some security focus items, whether that's PCI compliance, integrating with HSMs to make it easier for customers from a compliance point of view. And one thing that is a super, super important focus, and you'll learn more if you're in the breakout session for Redshift, is a focus on performance and making sure that will deliver you the amount of the kind of performance that you really want. And the last service that I'd like to talk about before Lisa comes and talks to us in a little bit more detail about how the cloud is useful for open data is Data Pipeline, another service that we started talking about at around this time last year. So something that makes it easy for you to create these different kind of data pipelines, taking data out of EMR, for example, ending up with it in DynamoDB or Redshift. So very reliable. Again, you choose where you want the data to go. Are there any data pipeline customers in the room out of interest? Okay, a few. So dragging and dropping and choosing where your data wants to go. You don't need to focus on those underlying pieces of infrastructure. It's that same kind of theme. You could go and roll that stuff. You could choose for us to do it for you. It could be something very simple. You're taking an input, taking that data, and ending up with it somewhere obvious. It could be really arbitrarily more complex pipelines. And the thing that some customers find attractive, like Swipely, you'll hear about them in the breakout session that we have later on and how they chose to use Data Pipeline. And when we were talking to them, they'd still been able to do this stuff in the past. But the difference was for them, they had to spend all this time, they had to spend all this engineering effort building this infrastructure to move their data around. And now what they like that they can do with Data Pipeline, they can make those changes within hours without having to do all of this complex stuff. So it's made that a really great thing for them. From a momentum point of view, we've added support for more regions. We recently announced the ability to be able to do copies involving DynamoDB as well, and recently added support for Redshift. So those are some of the innovations that we've made with Data Pipeline. And that's kind of the conclusion of the high-level overview of those services. This definitely wasn't intended to be a depth session, so if any of those services pique your interest, there are many more sessions in the big data track where we've got 200, 300, and 400 level sessions across those. So next, I'd like to invite Lisa Green on stage. Lisa is Director of Common Crawl, and she's going to spend a little bit of time talking about their data set and how utility computing is interesting for them. So please welcome Lisa.
Hi, I'm super excited to be here talking to you today about big, open data. We're on the verge of a new age right now. The age of big data is tremendously different than the age we were all born into. The difference between the world we were born into and the world we're entering now is as significant as the invention of the Gutenberg press. I mean, we now have the ability to access and analyze massive amounts of data. Data on a scale that would have been inconceivable just a short bit ago. But for me, the question is, in the age of big data, how much of that data is open data? Everyone should have the ability to access and analyze massive amounts of data. But all too often, talented data scientists or developers don't have access to valuable data sets. Let's take the web for an example. You probably think the web is open because you can go to a search engine, enter a query, get the results, read them, but you can only really read them with your human eyes and analyze them with your human brain. If you want machine scale access and analysis of web data, big data analysis of web data, you'd probably have to work at that search engine rather than just use their tool, well, until recently. So the web isn't the only kind of data that should be open, but it's one type. It's a type that I feel passionately about, and that's why I love my job, which is running Common Crawl. Common Crawl is a nonprofit organization that builds and maintains an open repository of web crawl data. And when I say open, I mean both gratis, that it won't cost you anything to access our data, and libre, that we don't put additional intellectual property constraints on it. It's web crawl data, which is tremendously valuable data. The web is a digital copy of our world. And being digital, that means you can run jobs against it. That means you can analyze it in ways that you could never analyze the physical version. But it's big. Our data sets measure in hundreds of terabytes, in the billions of web pages. And I just want to take a brief aside to talk about scale for a second. We say big data, we talk terabytes. Redshift is a petabyte level storage. But let's just put that in perspective for a second. I love this graphic. So if a byte is one character, by the time you get to gigabyte, you're talking about 4,400 books, and they have that human icon there to give you an idea of how big that many books are. And a terabyte, 1 terabyte, is 4.5 million books worth of data. So when I say our data sets are hundreds of terabytes, we need massive storage and massive compute. When you talk about any kind of big data, any kind of big open data, you need massive storage and you need massive compute. But you need it at a reasonable cost. I mean, what good is it to have heaps and heaps of data if working with it is cost prohibitive for an individual, or if working with it is crippling the profits of a business? And that's where Amazon comes in. Our work wouldn't be possible without Amazon Web Services. AWS enables anyone to access and analyze massive amounts of data. A developer with a laptop in a coffee shop can run a powerful job against big data and come up with valuable knowledge for less than the price of the coffee drink. And for groups and teams, companies, organizations that are well beyond the scale of price of a coffee drink, like my organization, I'm sure most of yours, it's still crucial. Amazon is still crucial for enabling our work because all of the savings, all of the brilliance that goes with elastic cloud compute, elastic MapReduce. Just use what you need, as we were hearing earlier. That means money saved, and then that money means more jobs on more data and more knowledge. So we couldn't do our work without Amazon Web Services, and I'm sure that's true for a lot of you here too. The Common Crawl data lives on Amazon public data sets. This is a very valuable program from Amazon. There's tons of open data there that you can use without intellectual property restrictions. This is a great place to get started using big open data. It has every kind of data you would want. It has genomic data, it has geography data, it has an entire copy of Freebase, and of course, the coolest, most interesting kind, web crawl data. Okay, so why is web crawl data the most interesting? What can you do when you have a copy of the web integrated with EC2? I'm so glad you asked. I'm going to run through a few examples of things that have been done and are being done with Common Crawl data on Amazon platform, with the intention of inspiring you to think about things, new things that you could be doing with big data, with big open data. The first examples I want to talk about are in the category of web science, studying the nature of the web. This is a study called Web Data Commons. It's a project, it's a collaboration of German academics, and this looks at metadata formats, adoption and usage of metadata formats over a 4-year period. How does RDFA holding up against microformats? This is really valuable work, especially as we move to more and more semantic technology, so we understand the nature of the web. We also have a relatively new project with Mozilla called Caravella, which studies the nature of the web from more of a front-end perspective. What development trends how are they changing? If the web had a favorite color, what is it this week? What was it last week? What was it last year? So again, understanding the nature of the web, which is crucial considering how much of our lives rely on the web. Business, social, family, health. The next examples are in the category of machine learning. So I said before that the algorithms that we have now for analyzing big data are so powerful and are evolving so quickly. But you need data to train your algorithms against. And a lot of work has been done with common crawl data on Amazon in areas of language analysis. For example, SwiftKey is a London-based company which does language analysis and text interface with specialties in minority languages. So if you want to train an algorithm to do, say, autocomplete in Basque, where are you going to find a large enough body of text in context but the web? So they use Common Crawl data and Amazon Web Services to do their language analysis algorithms. This is a recent paper, I think it's about 5 months old, where a group of American academics showed that using Common Crawl data and Amazon Web Services for machine translation work was not only a much better cost, as the title makes abundantly clear, but produced better results. The third of the 4 categories of examples I'd like to talk about is sentiment analysis. So this is some open source code, a GitHub repo, for some open source code called Bill Tracker. Bill Tracker says, show me every web page that mentions a congressional bill. Now show me the top N words that are associated with that congressional bill on that web page. Now run a sentiment analysis against those N words. And what you have is online sentiment toward congressional bills. And I'm sure you can imagine how this could be used for products or companies and not just for congressional bills. And in fact, it is being used and has been used in that way. But you can also imagine that companies aren't really thrilled about me standing on stage and telling you about their secret sauce. So I put up this to say, I'd like you to think about what would you like to measure the online sentiment towards. Maybe it's a hobby or a pet interest. Maybe it's something directly related to your business. And I put it up to emphasize the fact that there's a lot of open source code available working with Common Crawl data and other types of data on Amazon. It's a great place for jumping off. There's a lot of code for you to crib from, and some of it you can just drop right in. I'm running over, so I'm not going to mention this other open source project. It's a sentiment analysis that analyzes YouTube comments to help you find the best and the worst YouTube videos. Let me tell you, there are some terrible YouTube videos out there. And the last category of examples I'd like to do is what I call knowledge discovery. This is a side project that was done by an engineer at Imagineer, and he just was out of curiosity. He wanted to know about the demographics of bloggers. He wanted to know some statistics about bloggers, purely out of curiosity. So he wrote some code that said, pull all of the bios and profiles from bloggers out of the corpus, and then extract some facts like location, topics that they blog about, gender and age and things like that if they're available. And he came up with some interesting things, like 25% of all bloggers in Bangalore write about music, because evidently Bangalore is the music capital of India. Did anyone know that? Okay, 17% of bloggers in San Francisco write about politics. See, I love that one because it says not everyone in San Francisco is just obsessed with tech. Some people are also thinking about the bigger picture of the world. But this is just him satisfying his curiosity. But I want you to think about what kind of facts would you like to extract from the internet on a machine scale, on a big data scale. And this is my last example. I love this story. This is called Lucky Oyster. The founder of Lucky Oyster was a developer and an entrepreneur. He was in between startups. And he had some questions about what information is on the web and how is it organized. So he spent about 2 weeks formulating his questions, writing his code, running his jobs. He spent less than $200, ran it on spot instances. Spot instances are the best. less than $200, and the information that he got back, the information that he extracted from the web, was the inspiration for his new startup, Lucky Oyster. Within 2 months of running those jobs on Amazon against common crawl data, he had venture backing. Last year he came to reInvent with me and stood and told the crowd how he had just got funding and he was working on his product. Now you can download it on the App Store. And I love this story because what it says is an individual, one guy with curiosity, is empowered by Amazon Spot instances in just a few $100s, and it builds to a company. And in that way, big open data and the accessibility enabled by Amazon can lead to economic diversity, it can lead to new technologies, it can lead to the egalitarianism of one curious coder, and you don't have to be in a giant corporation. So I hope these handful of examples have inspired you a little bit about what you can be doing with big data, with big open data. And I hope that you will go to Amazon Web Services Public Data Set and start playing with the data, especially common crawl data. Thanks.
Thanks very much, Lisa. So, I mean, where does this leave us? We've had a look at how we think about the concept of the data timeline. We've seen Scott talk in his words of how AWS's capabilities and kind of the utility computing model can make a big difference to his business. And hopefully given an overview of how some of these different puzzle pieces that we have exist, and you can think how they can potentially be put together. Now I don't know who's seen this thing before, the kick-ass curve, as it's called. I kind of found it difficult to read the first time, but I think it is something worth bearing in mind when you think about the different tools that we have for manipulating big data, and you think about what you have in terms of people in your company, people in your organization, that you don't, if you've got a set of people who love SQL, maybe you want to give them a solution that gives them the interface that they can use, or using some kind of Excel solution with something like Redshift. You know, choose the thing that's not going to make your users think it sucks for too long so they can actually be productive. So I found it quite funny. To close, what we're all about with our big data solutions, with what you will learn in this track, is providing you with different tools and technologies so you can work with this data at any scale, and then to a stage where you're unconstrained. And whether that's unconstrained in a large organization like Channel 4, where they can suddenly process all of this data that they couldn't, whether it's someone in a coffee shop who's doing work with big data that they couldn't do in the past, or they couldn't do easily. Both of those type of scenarios, removing all of that friction. So where next hear from you? I was going to try and put together a slide giving sessions in the big data track for you to go and see, but couldn't fit them all on. So there are at least 24 more sessions that you can go and see just in the big data track. So if there was anything that you found interesting in this session, whether you wanted to go deeper on DynamoDB, you wanted to learn how to optimize EMR, Elastic MapReduce in a 400 level session, I hope that in this catalog of 24, you'll be able to find something that piques your interest. And if you want to learn more beyond those sessions, come and visit us at the expo in the booth. We'll have product managers from the various service teams who can go as deep as you like on any one of those individual services. We've got our solutions architects who spend their entire time working with customers, helping build them solutions. We'd love to talk to you. We'd love to hear what we can do better, what we can build for you, or help you with any of these solutions. So please do give us feedback. We try and build these presentations to make them useful. If there's stuff we could have done better, if there's other stuff you'd like to see in this kind of session, please tell us if there's any way we can improve. We'll have a few minutes for questions. If you have questions, I'd prefer that you pose those that you might have for Scott or Lisa. You'll get a chance to talk to AWS people for the rest of the conference. You certainly won't get a chance to talk to Scott and Lisa. But other than that, thank you for your time. Hope you enjoyed the keynote. Enjoy the rest of reInvent. Thank you very much.